The rhythm of the drops, drip by drip, is the very first beat in the creation of a professional soccer ball.
This inherent elasticity is the physical property that makes a soccer ball fly off a player's boot.
Opening the mold.
The hot bladders are immediately inflated with air to check for leaks. They expand into shiny, perfect globes.
This ugly black balloon is the secret to the aerodynamic stability of a soccer ball.
The elasticity check. A mechanical arm squeezes the inflated bladder and releases it. It snaps.
The polyester fiber is thin but incredibly high tensile. It prevents the rubber bladder from overexpanding.
The wound bladder is a textured white globe. The surface is rough with crisscrossing threads, which provides the grip needed.
The weighing station. A digital scale displays the weight of the carcass. It is critical. If the thread winding is too
The transformation from a weak rubber bag to a reinforced pressure vessel is the engineering secret of the soccer ball.
This synthetic material is the modern, waterproof skin of the soccer ball.
Unlike old leather, this synthetic skin ensures the soccer ball never gains weight during a rainy match. Precision is vital. If the skin is uneven, the finished soccer ball will be unbalanced and fly erratically. This 3D structure is not just decoration, it increases the friction between the soccer ball and the player's boot for better spin control.
Aside from the microtexture, larger aero channels or debossed lines are pressed into the material.
Instead of creating a slick film, the water is broken up by the micro bumps. This ensures the soccer ball remains grippy even in a downpour.
Different brands use distinct geometric shapes. This pattern acts as a fingerprint, identifying the specific model of the tournament-grade soccer ball.
This is where the soccer ball gets its identity.
The printer applies a layer of gold or silver shimmer. These specialized pigments catch the stadium floodlights.
Detail of the FIFA-quality Pro logo being printed. It is a small but critical stamp. Using high-precision screens, the tiny letters are crisp and legible.
The registration mark close-up. Tiny crosshairs are printed in the corners of the sheet. These fiducials will guide the laser cutter in the next step.
Standard ink would shatter upon impact, but this formula is engineered to survive the deformation of a soccer ball.
Colorimetry. Delta E 0.2.
As the laser cuts, the heat instantly melts and seals the edges of the polyester backing cloth. This prevents fraying and ensures
The machine uses a camera to spot the registration marks. It adjusts the cutting path in real time so the printed logo is perfectly centered on the soccer ball panel. Artistic texture shot of the cut edge. It is brown and slightly scorched, a hallmark of laser cutting. This rough surface will
A bore, a blocky 90-degree edge. After, a smooth 45-degree bevel.
the scoring process. The machine cuts a shallow groove just inside the edge. This acts as a hinge, allowing the stiff synthetic lessings. The smooth backing cloth is gone. The rough, porous foam structure of the inner layer is exposed. This roughness It reads 0.8 millimeters. Precision is vital. If it's too thick, the seams will protrude. If too thin, the soccer ball might burst on impact.
Tapered edges, coated in dry glue. They are no longer just fabric shapes. They're engineered components ready to build a soccer ball.
Tiny, invisible holes inside the metal mold suck in air. This force holds the slippery PU panels firm.
Macro focus on the seam interface. The dried glue on the edges is visible. It is cold now, but ready to melt and fuse the soccer ball forever. Inside this dark metal chamber, the disparate parts are about to become a unified soccer ball.
The internal bladder is inflated with hot air. It expands aggressively, crushing the panels against the hot metal walls. The embossing effect under heat. The heat softens the polyurethane skin. The pressure forces the material deep into the microtexture of the metal mold walls.
The recipe must be exact. Too hot and the plastic melts. Too cold and the soccer ball will fall apart during a game.
Extraction.
The hot balls are placed on ring stands. Fans blow cool air over them. As they cool, the glue hardens and the materials set.
A traditional hand-stitched seam with visible thread holes. The thermal bonded seam of the soccer ball is smoother, offering less air resistance and drag.
This weight counteracts the mass of the valve, preventing the ball from wobbling in flight.
A microdispenser drops a single bead of clear glycerin or silicone oil into the valve opening, ensuring the inflation needle slides smoothly without tearing the seal.
We look down the throat of the valve. We see the slit in the butyl rubber. It is squeezed shut by the internausher.
The valve stem must sit slightly below the surface. If it protrudes even 1 millimeter, the soccer ball is rejected as defective.
The inflated ball is placed on a high-speed spinner. Sensors measure vibration. If the valve and counterweight aren't perfectly
only 0.1% weight gain. The thermal bonding means it absorbs virtually no water, staying light and fast.
The rebound test requires a drop from exactly 2 meters. The sensor
The soccer ball sits inside a heat chamber at 60 degrees Celsius. This checks if the glue melts or the panels peel off in
After 2,000 kicks, the ball is measured again. If it has become egg-shaped, deviating by more than 1.5,
The gold pigment catches the light, sitting slightly raised. This stamp signifies the ball meets the highest standards of
the serial number laser etching. A tiny laser burns a unique alphanumeric code. This provides full traceability.
Polishing.
This premium soccer ball is not deflated. It is kept at a low pressure, about 6 psi, to maintain its shape and protect the glossy surface.
The needle settles exactly on 1.0 bar. This is critical. If the pressure is too low, the soccer ball will be sluggish